Hello everyone. Today's class we are going to start about the enzyme catalysis. Okay, enzyme is a biochemical reaction. You can say biochemical, which is present in the animal body or plant body, and which carried out various type of our biological reactions or biological process. Now, how can we define? Okay, define numerous number that occur in the numerous reactions that occur in the bodies of animal and plant to maintain our life process. Okay, to maintain our life process are catalyzed by enzyme. That means with the help of different kind of enzymes, we are we are having different kind of reactions, and these reactions are known as enzyme catalysis reactions. Remember, enzyme is known as biochemical catalyst. That's why the reaction is known as biochemical catalysis or enzyme catalysis. Okay, now let us take an example. To example, in your book maybe 7 or 8 examples are there. Okay, from them I just take 2 examples. First example is the conversion of glucose to ethanol. When glucose molecule is react with gymase enzyme, which is comes from the yeast, it produces ethanol and carbon dioxide, and this process is known as fermentation. Okay. Second, the very well known example is the conversion of milk to curd by lactobacilli enzyme. As you know, if we kept milk for more than 12 or 20 or 24 hours, our milk converted into curd with the help of lactobacillus enzyme. Okay. Now main thing is the what are the importance or what are the characteristics of enzyme catalysis. Okay, see, main thing is the how we are using enzyme nowadays in very much extent. Okay, now see, enzyme catalysis has some specific characteristics. Suppose I'm writing characteristics of enzyme catalysis. Okay, first characteristics is the it is most highly efficient. Okay, second is the highly specific in nature. Highly specific in nature. It means with the help of particular enzyme and particular reactant, we can produce particular types of product. This is the main meaning of highly specific in nature. Okay. Number 3 characteristic is the highly active in optimum temperature. That means the enzyme catalysis reactions don't need so much of high temperature. It can carried out in the optimum temperature. That means the normal temperature, you can say, or you can say our body temperature. Okay. Next characteristic is the highly active in optimum pH. The pH range is nearly 5 to 7. 5 is not so much acidic and 7 is the neutral. That's why it is optimum range. Okay. Next, increasing activity in the presence of activators and coenzymes. Activator and coenzymes are the substance which are increases the activity of a enzymatic reactions. Okay, So let us take an example such as sodium positive, magnesium 2 positive, cobalt 2 positive, and copper 2. These are the ions which act as a coenzyme in the enzymatic reactions and what? And increases the enzymatic reactions. Okay. Next is the influence of inhibitors and poisons. Okay. In the presence of some certain substances in the enzymatic reactions, the efficiency, or you can say the function of enzymatic reaction, is little bit dif different or little bit decreased, you can say. Okay. This type of concept, that means the influence of inhibitor and the poisons, are widely used in the medicinal chemistry to make a particular medicine. Now, let's see what is the mechanism of enzyme catalysis. Okay, that means how the enzyme catalysis is performed. See, it involves two steps. In the first steps, the binding the enzyme to the substrate. Substrate means the reactant, to form an activated complex. Activated complex means, as I explained, activated complex is the complex having high energy and highly unstable. Okay. Now see, when E means the enzyme, S is the substrate, or you can say the reactants. When it binds the enzyme with the substrate, it forms the ES star. That means activated complex. Star means highly unstable and high energy. Okay. Now see, the second step, this activated complex is decomposes to form product. When this activated complex decomposes to form product, mainly the mechanism of enzyme catalysis is explained by a well-known theory known as lock and key theory. Let us see how. Now, if you write these two steps in a single step, okay. Now see, when enzyme binds with substrates having some active sites, okay. Now, suppose let us take this one is an enzyme and act as a key, and this is the substrates. Substrates have some active sites. These are the active sites. And active sites is formed due to the presence of some active group which can bind with the enzyme, and these active groups are mainly ammonia, carboxylic acid, hydrogen sulfide, or OH, etc. Okay. Why this nitrogen compound, carbon compound, sulfur compound, oxygen compounds? The enzyme binds to the substrate. Substance means reactant, and this is known as the what? Lock. This lock. Now, if you see clearly, this one is a lock, and lock usually in our home, lock has a particular hole in which the particular key is fitted. That's why for particular substrate, particular enzyme is here. That's why it is known as highly specific in nature. Okay. Now see, when this key, that means enzyme, binds via these active sites to the enzyme, to the substrate, that means the reactant, it produces a enzyme substrate activated complex. This one is a activated complex ES star, which is in high energy. Again, in the next step, this activated complex having in high energy decomposes the reactant and the different product. Okay. See here, the enzyme which is acting as a catalyst, we have same before and after the reaction. Okay. That's why enzyme is acting as a catalyst and forming a reactant to the product, but the catalyst, that means enzyme, remains same throughout the reactions. Okay. Understood now? Next. Now we are going to start about the colloid. Okay. Now, our next topic is the colloid. To know about the colloid, we have to know what are the differences between the colloid suspension and the solution. Okay, now see. First of all, we'll see solution. Solution is a homogeneous mixture, or you can say pure mixture. Okay, now what do you mean by homogeneous? Homogeneous means, let us take an example for that. Okay, now when suppose here is 3 beaker, okay, similar beaker, in each beaker we are taking lots of water. Okay? The first beaker, which is a solution, when we add sodium chloride, to a beaker containing lots of water, obviously the sodium chloride will dissociate and produce a clear solution of sodium chloride, and the solutions contains sodium positive and Cl negative, which is mixed throughout the solution. Okay, now what are the properties of solution? You can say this is the clear solutions. Okay, clear transparent solutions. This is the true solutions, and the size of molecule or ion in this solution is very small. We cannot see with naked eyes, and this does not show Tyndall effect. Tyndall effect means the light, if the light can reflect throughout the solutions, will show the Tyndall effect. But here it is clear solution. No, the light can pass throughout the solutions, not reflected. That's why the true solutions or solutions does not show Tyndall effect. Okay. Now next section is the suspension. Suspension means a heterogeneous mixture. And now what is heterogeneous mixture? From the heterogeneous, we can say hetero means different. Okay, different. When we add sand to a beaker containing lots of water, the obviously when we stirred with a glass rod, okay, this one suppose a glass rod. When we stir with a glass rod, obviously for some time the sand is moved throughout the solutions. But when you kept rest, when you kept untouched for some time, obviously you can see the sand is saddled down. But a very small amount, very less amount of sand is moving throughout the solutions, which makes the solution is little bit cloudy. But it is not so much cloudy to reflect the light, which is known as Tyndall effect. That's why suspension also does not show the Tyndall effect. Okay, the molecule, or you can say the ion or atoms of the sand, can be seen by our naked eyes. That means the particle size of the sands in this solution is little bit larger. Okay, next is the very important topic is the colloid. We'll discuss more about the colloids. Okay, stepwise. Now, first of all, see, colloid is a homogeneous mixture. Homogeneous means the this one is a, suppose in a beaker we have taken lots of water and we are adding milk from outside. Here milk, for that colloid concept, milk is known as dispersed phase. Milk, I'm writing here. Okay, milk plus water is the suppose mixed solution. This one colloid, but this milk is known as dispersed phase. Dispersed phase. Dispersed phase. Dispersed phase, nothing but the solid. Okay, in colloid concept, the solid is termed as dispersed phase, and the medium or the liquid, you can say the medium may or may not be liquid. The solvent part is known as what? Dispersion medium, or you can assume with the solvent. But particularly for colloid, the solvent is known as dispersion medium. That means dispersion medium is the medium in which the dispersion phase is dissolving. isn't it? Okay. And dispersion phase is the substance which is going to mix, or you can say dispersed, in a dispersion medium, that means solvent. Okay. And the solution is known as colloid. Now, what are the properties of colloid? Let's see. When we add milk to the water, we get colloid. Okay. Now important properties of colloid. Let us see. First important properties of colloid. It is homogeneous mixture. That means milk is mixed throughout the whole solution. That means uniformly mixed. Uniformly mixed. There. Now, what is the meaning of uniformly mixed? Now, if we take 1 spoon of milk solution from here, we draw out 1 spoon of, suppose this one spoon of, 1 spoon, here is spoon of milk solution. This milk solution has the same concentration, you can say same component with this solution. From the solutions, from anywhere, if we take a little amount of the solutions, is the same as that of the whole solutions. That's why it is known as uniformly mixed throughout the solutions. Next point is that it is the cloudy. It is the cloudy solution. Okay. If it is cloudy, then obviously the light reflects. When you pass light throughout this milk solutions, light will reflect. That means the milk solutions, or you can say colloid, shows the Tyndall effect. Okay. The particle size of colloid is not so much big or so much small. Okay, but we can't see without naked eyes. Okay. Next, very important topic is that there is no effect of sedimentation, and sedimentation means to settle down the dispersed phase in the lower layer of the container. Okay, there is no effect of sedimentation. That means the milk will never sediment in the appropriate pH in the beaker. But if you see here in the suspension, sand will settle down when we keep rest for some time. But here also there is no effect of sedimentation. That means the sodium chloride will never sediment or settle down in the lower part of the container. Okay, this is the main concept or main differences, or you can say main comparison about the colloid, suspension and solution. Next is classification of colloid. Okay, colloid are classified in the basis of 3 properties. First, colloid are classified based on physical state of dispersed phase and dispersed medium. Okay, that means the classification based on physical state of dispersed phase and dispersion medium. What is the meaning? That means in which states dispersed phase and dispersed medium are mixed to make a colloid solution, or you can say colloid. Okay. Next, classification based on the nature of interactions between the dispersed phase and dispersion medium. That means what type of bond or what type of interactions is having in between the dispersed phase and dispersion medium. Okay. Third, classification based on the types of dispersed phase. That means how the dispersed phase, or you can say what type of particles of dispersed phase is mixing with the dispersion medium. Okay, depending on the types of particle of dispersed phase, colloids are classified. Okay, now see, first one, based on the dispersion phase and dispersion medium, salts are classified in a different categories. Okay, now see, first one, here is the dispersed phase, dispersion phase, dispersion medium, types of colloid, and few example. Okay, now see, first one, if the dispersed phase is solid and dispersion medium is solid, then the types of colloid is known as solid salt, not salt. Remember, it is sol, S-O-L, salt. And the example is colored glass and gemstones. Okay, colored glass and gemstones. Second, When the dispersed phase is solid and dispersion medium is liquid, then this is known as sol, only sol. And the example is paint and cell fluid. Cell fluid means what? Cytoplasm. Okay. Now, here is a particular case. Now, if the dispersion medium in place of liquid, that means particularly if it is water, or alcohol, then the solid, that means the colloid types, is particularly known as, for water it is hydrosol. Hydro means water, sol means salt. Hydrosol. For alcohol it is known as alcohol. These are two particular cases. Okay, these two words very important. Maybe 2016 or 15 in CBSE board exams, if a question asked is the what is the difference between the hydrosol and aquosol. Hydrosol or aquosol. Hydrosol is the sol in which dispersion phase is solid and dispersion medium is water, and aquosol, and the alcohol is the sol in which dispersion phase is solid and dispersion medium is alcohol. Remember, this hydrosol has another name, is called the aquosol. Aqua means water, hydro means also water. That's why hydrosol or aquosol. Okay, next section. When the dispersion phase is solid and dispersion medium is gas, it is known as aerosol. And the example is smoke or dust. Now see, if we just observe in the dust or smoke, lots of gas is there and lots of dust particle also there. Dust particles are the solid, that means dispersion phase, and dispersion medium as the gas, that means the air. When the dispersed phase is liquid and dispersion medium is solid, then it is known as gel. Gel means cheese, butter, or what? Gel. Okay. Next, when the dispersed phase is liquid and dispersion medium is gas, then that is known as aerosol. Another aerosol, and the example is fog, mist, or cloud. Okay. Next, if the dispersed phase is liquid and dispersed medium is also liquid, then is known as emulsion. Emulsion, that means the milk, hair cream, etc. Okay. When the dispersed phase is gas and dispersion medium is solid, and it is known as solid sol. Solid sol, and the example of solid sol is foam. Next, and the last is, when dispersed phase is gas and dispersed medium is liquid, it is known as foam and is whipped cream. Sorry, the last one is when the dispersed phase is gas and dispersed medium is solid, it is known as solid sol, and the example is foam. And the last, when the dispersed phase is gas and dispersed medium is liquid, it is known as foam, and the example is whipped cream. Okay.